There are many different ways that we measure behavior. These are just a few of them, and we will focus in on each of them individually. Methods of measuring behavior can be thought of in different categories. Event recording addresses number of times a behavior occurred, or frequency, which we'll talk about later. There's also timed behaviors, and these are in two separate categories. It's important to note that there are different methods because you might want to look at different dimensions of a behavior. In order to choose the best method, it's important to ask yourselves a few questions. Does the behavior have a clear stop and start time? Meaning, is it a discrete behavior and is it easy to count? Does the behavior happen over time? And does it last a long time? Is it happening frequently? Is it happening in a continuous or ongoing way? One reason it's important to know as an RBT all of these dimensions is that you could be a part of the process for determining what method to use. Although the best advice would be, if you're unsure, ask your supervisor. Frequency data is measuring how frequently or how often a behavior happens. A good way to remember this is to say frequency count in your head. That helps me to remember that I'm counting the behaviors. One example of when to take frequency data would be if a child is screaming. However, we have to be sure that the scream is discrete in nature, has a very clear start and stop time, and is easily counted. Rate recording is similar to frequency, but it involves a unit of time. You can see in the equation I listed, frequency of behavior is in the top part of the equation, and unit of time is in the bottom. Oftentimes, it is worded as the behavior per whatever unit of time. So for example, 7 hits per minute. A second example would be if there was 16 screams per hour. Note that the frequency of the behavior is in yellow and the unit of time is in red. Take a moment to look at the following examples and determine if they are rate or not. Take a look at what I highlighted. Note that in some of the examples, there is yellow but no red. That's showing you that there's no unit of time, so it simply can't be a rate. For the example of 20 slaps, what do you think it could be instead of rate? That's right, the answer is frequency. It's still a count of behavior, but there's no unit of time, so it's not rate. For the 37 seconds of screaming, we have a behavior and we have a length of time, but we don't have a count, so it's not frequency or rate. What we'll talk about next will answer the question of what unit of measurement we're using here. Sometimes it's more important to know how long a behavior is happening, especially if the behavior is not discrete in nature or the length of time of the behavior is longer than a few seconds. If a child screamed for 45 minutes, it would be more important to look at the dimension of duration because if we were measuring it in frequency, it would say a frequency count of 1. But in terms of behavior reduction, we'd want to see the length of time the child was screaming go down. If we instead measured it as frequency, the frequency of that behavior might stay the same over time, but the length of time the child was screaming went down. This is a great example of why understanding dimensions of behavior is important. Another example of a time-based measurement is latency. I feel as if the best way to understand latency is through an example. So for example, the teacher gives the direction, touch the dog, and 4 seconds later, the client touched the dog. The teacher direction, touch dog, is an onset of a stimulus, and how long it takes the child to start completing that task 4 seconds later is the latency. One thing to note about latency is that the timer should not be started until the stimulus is complete. What I mean by this is the timer shouldn't be started when the teacher begins to say the word touch, but when she's finished saying the word dog. The reason this is important is because if we are going to teach the child to respond more quickly, we would want them to wait for the entire direction to be given as opposed to jumping the gun and starting before they know exactly what's being asked of them. Take a few minutes to look at these examples and determine what the onset of the stimulus is and the time that it took for the child to respond. In the first example, the onset of the stimulus was the bell ringing. The latency would be 5 minutes. The next example is an internal event, but because I can indicate when that stimulus happened, it's okay for that to be an onset stimulus. The latency here would be 15 minutes. In the last example, I hope you noted that there was no onset of a stimulus. This is not to say that there is one that we aren't aware of, but just having this little information is not enough to say that 3 seconds is a latency. Inner response time is the elapsed time between two responses. I believe this is also better explained in an example. So for example, a child screams, 13 seconds passes, and the child screams again. The time in between these screams, the 13 seconds, is the inter-response time. The difference between inter-response time and latency is what comes before it. For example, in latency, the onset stimulus comes before latency data is taken. In inter-response time, the first instance of behavior occurs before inter-response time data is taken. It's very common for people to get these two measurement systems confused. So take a few minutes to look at the 4 examples given and write down if you believe it is latency or inter-response time. Feel free to go back and review the 2 previous slides in order to give the right answer the first time. As a visual aid, I've highlighted latency in blue and error response time in red and yellow. If you have further questions about these concepts, please stop the videos now and go ask your supervisor for clarification. Another time-based measurement system is time sampling. Sometimes this is known as interval recording. Partial interval recording occurs if a behavior occurs at any point in the interval, then it is indicated as occurring. Whole interval recording is if a behavior occurs the entire length of the interval. Momentary time sampling simply specifies a specific point in time that a behavior would occur, and if it does, then that interval is noted as the behavior occurring. An example of this would be to have 1-minute intervals. If a child screams at any point during the 1-minute interval and behavior data is taken, that would be an example of partial interval recording. In whole interval recording, it would be necessary for the behavior to occur the entire length of time. So if the child screamed for the entire minute interval, then it would be noted as the behavior occurred. In momentary time sampling, if screaming happened at the 1-minute mark, then behavior would be noted as occurring. As you might have predicted, these would result in different levels of behavior being recorded. Depending on the interval recording or momentary time sampling that you use, you might get an underestimation or an overestimation of the behavior. Therefore, it's necessary to take a good look at what dimension is most important for you and measure it accordingly. When doing interval recording, it's necessary to have a legend for yourself so that it's very understandable when a behavior occurred and didn't occur. For the purposes of this, we will say that an X means that there was an occurrence of behavior, and an O would mean that there's a non-occurrence of behavior. It's necessary to mark both so that when a supervisor or someone else who's analyzing it knows specifically what happened and what didn't happen. Typically, for momentary time sampling, it is marked in the interval if the behavior occurred at the end of the interval, at the very end. So for example, if there's a 1-minute interval, at the 1-minute mark, if the behavior is occurring, there would be an X. Let's take some time now to look at videos and practice taking this data. In your packet, you'll find 3 rows of intervals. Each interval will be 5 seconds long, and we'll watch the same video and take data on each different type of measurement. We'll take data on partial interval, whole interval, and momentary time sampling. The videos will already be paused for you, so feel free to take data as the videos play.
What do you do with the car?
Drive it.
Yeah, you can drive a car, you can ride in a car. It's good.
It's a blue one.
It is not a blue one.
A car.
Yeah. What color is this?
Green.
Yeah. What do you do with the car?
Drive it.
Yeah, you can drive a car, you can ride in a car. It's good.
It's a blue one.
It is not a blue one.
A car.
Yeah. What color is this?
Green.
Yeah. What do you do with the car?
Drive it.
Yeah, you can drive a car, you can ride in a car. It's good.
It's a blue one.
It is not a blue one.
Red car.
Yeah. What color is this? Yeah.
In order to calculate what percentage of intervals the behavior occurred, you'll need to take the number of intervals in which you marked an X and the total number of intervals, which is 3, and divide it. Then you want to times by 100. What you'll notice is that you might have gotten different percentages depending on what measurement system you used. Take time now to complete the calculations and write them down in your packet. Permanent product is a measurement in which the behavior produced a change on the environment, and that can be measured after the fact. For example, an assignment being ripped up can be seen after the behavior occurred, meaning it doesn't necessarily have to be observed, but you can tell that the paper was ripped because the behavior of ripping it left a permanent change on the environment. A better example of this might be the number of completed homework problems. You can tell that this occurred because there will be an answer written on the paper. The next example would be tokens for appropriate behavior, and you could see this by how many tokens were placed on the page. A more systems example would be the number of referrals. This could be data taken by a report given by administration. You'll note that in all of these examples, the behavior that we're measuring was not observed directly. Instead, we looked at the product that behavior had on the environment and took data accordingly.